This is a question from the 2024 Deferred paper, paper 2, and it's question 9 in section B, and it's a question on statistics and probability. So the question starts off with a scatter plot showing the connection between the weight of players and the height of players in rugby, on a rugby team. And we're asked in part I to estimate the correlation coefficient for that graph. So what that means is, we got to figure out, what's the connection here, how are they correlated, and we can see first of all that it's generally going it's increasing. The height of the players increases in general with the weight of the players as the weight increases. So that's the general trend. So first of all, there's a positive correlation because there's that general trend. Also, it's a strong positive correlation because it's fairly predictable. They're all fairly tightly bunched, and there are not that many extreme exceptions or anything like that. So we say it's a strong positive correlation. So if you want to put an estimate of a correlation coefficient on that, it's a positive number, a higher positive number. So 0.9 is the only candidate for that there, really. So the answer is 0.9. And the reason is, as I said, first of all, it's positive as weight increases, height increases, but also it's a strong correlation. They're fairly tightly bunched together, so it's a fairly predictable, strong correlation. Now, the next thing we're asked to do is draw the line of best fit. So what that means is, with the points we're given, try and find the line that I suppose goes through the middle of all those points and average them out as such. And so the line I picked here is this one. As you can see, that I do the best I can to make it go through the middle of most of the points. So that's my line of best fit. It'll vary slightly from student to student, as long as you're not too far off to give you full marks. The next thing we're asked to do is use the line of best fit to make an estimate from the graph, and we're asked in this case to make an estimate for the weight of a rugby player who is 1.8 meters tall. So if we go back and read off the graph, there's 1.8 meters. If you come across and down off the line of best fit, you get this point here. I'm estimating that's about 93 kilograms. If 90 is there halfway, that's about 93. So there's my estimate. And again, as long as you're not too far off, they will allow you full marks there. The next part is a classic Bernoulli trials question. How do we know it's Bernoulli trials when they don't say it? There's some clues here. Usually the Bernoulli trials is for score or miss, true or false. It's one or the other. There's only two choices basically. And so when they say miss, so that suggests miss or score, or in this case it's miss a tackle or make a tackle. So either way, it's one or the other. So that's one clue. The other clue is independent. Each time you do this is a separate trial. It's independent of what happened in the previous trial. So these are all clues that it's Bernoulli. Now the first part is straightforward enough. We don't need Bernoulli yet because the only thing we need to do is interpret the English correctly, convert the English to maths. So read this very carefully. The fourth tackle in the game is the first one that is missed. What are they really trying to say here in maths language? To keep it simple and logical, they're saying that basically you make the first three tackles, you're successful, and you miss the fourth. If you think about what they're saying there, the fourth tackle is the first one to be missed. So you make the first three and then you miss the fourth. And now it's more logical and more convertible to maths. And if you again take the case of a miss, well, the probability is 0.08. We often call that Q in Bernoulli trials. And the probability, therefore, of making a tackle is the opposite, which is 0.92. It's 1 minus the miss. Okay. So the probability of making the tackle is 0.92. So we want to make the first three. So the first one and the second one and the third one. So and means multiply. So you basically take 0.92 by itself 3 times, or cubed. The word and in probability means multiply. You multiply your answers. So that's a direct conversion there as well. If you lay out your work properly, the maths tends to come out naturally. Miss the fourth. We want to miss the fourth, so that's 0.08 is the chances of missing any shot, and they're all independent, so it's 0.08 no matter which shot you're taking. Now, so you want this and you want this, so that means multiply your two answers, and you get the final answer, 0.0623. Part 2. Again, we have to convert English to maths. That's the secret in these Bernoulli trial questions. Find the probability that the team miss at least 2 tackles. What are they saying here in maths language? Well, if you miss at least 2, that's the opposite of missing 0 or 1 tackles. If you think about that for a second, you miss, it's 2 up to 20. There's up to 20. There's 20 tackles. So at least 2 means 2, 3, 4, 5 up to 20. In other words, you're not missing 0 or 1. So if you phrase it like that in more logical language, we're going from English to logical, and we can convert logical again into maths in the next step after that. So in Bernoulli, you have to do each one separately. So the chances of missing 0, try that first. Then the chance of missing 1. Okay, so what are the odds of missing 0? In other words, that's the same thing as making all 20 tackles successfully. Well, a successful tackle is 0.92, so 20 of them is 0.92 to the power of 20. So that's fairly straightforward, 0.1887. The other possibility is that you miss just 1 tackle, and you're successful for the other 19. So the way to say that is miss 1, which is the same thing as saying make 19 tackles. So that's a pure Bernoulli trial, because there are now 20 trials. You're doing it 20 times. You want to be successful 19 times. So the chances of success are 0.92. So it's 0.92 to the power of 19, going by the formula up here. And you want to miss once. 0.08 is the miss. So if you lay out your... So a miss is usually called Q, and a success is called P in the formula. So that's where they're coming from. So there's your formula, 20C19, 0.92 to the power of 19, 0.08 to the power of 1. You work that on your calculator and you get 0.3282. Now, in terms of the logic of the whole thing, what we're looking for, miss at least 2 tackles. That's the same as not missing 0 and 1 tackle. What is not in probability? Well, it's 1 minus. And you're going to add these two together. So there's the two situations. You're going to take that one and that one, so you're going to add them, the two probabilities, and it's 1 minus that for not. And you end up with the answer 0.4831. That's the odds. That's the probability of the outcome you're looking for. Part C. What we've got here is a table with points and the probability of getting those points in the next row. And the probabilities are given to us in terms of as X, Y, and Z. Now we're looking for the expected outcome. So if you keep playing this game or whatever it is, what's the average outcome that you're going to expect, basically. So that's this formula here. The expected outcome is basically the sum of the x's by the probability of x, if you call these x's up here. So points by probability of points in our case. So you just take your 7 by x plus 5 by y plus 0 by z. And you put all that together, and you're told the answer is 1.155. Now also something else, convert English to maths here. The probability of getting 7 points is 4 times the probability of getting 5 points. What they're trying to say there is this probability is 4 times this probability. In other words, x is 4y. So all that piece of text there can be converted to simply x equals 4y. And then what you obviously do is sub in for x down here, 4y, and you get 7 4 is 28 and 5 is 33y altogether. And now we can calculate y quite easily, 0.035, which is the odds of scoring, in this case, 5 points in the game. So now we have the odds of scoring 5 points. We can also get x, because x, don't forget, is 4y. So it's 4 times the odds of that. So 4 times 0.035 is 0.14. And now the last piece of the jigsaw is all the probabilities together must add up to 1. X plus Y plus Z. So you have to be someplace in these three categories. So they all have to add up to 1. So now you just take X plus Y plus Z as 1. And we have X and Y. And that allows us to calculate Z by subtraction from 1. That's the end of that question. Actually, there is one more part. So again, they added on this last part here. And this is a case of picking 3 people from 7. If you're picking a team. Now, when you're picking teams, the order doesn't matter. It doesn't matter which 3 you pick in which order. So when the order doesn't matter, it's always C. There's 2 choices usually, C or P. C for combinations, P for permutations. And when it doesn't matter the order, you're picking any 3 players, it's just simply 7C3, which on the calculator works out to be 35. And part 2. So on Saturday, you pick 3 forwards from 7. So we've already done that. The chances of the number of combinations of players you can get on Saturday is 7C3. And on Sunday, the number of players you can get, well, it's a bit different on Sunday because what you do is you pick 3 from the remaining 4. If you think about the 3 that you picked on Saturday, you must pick the 4 remaining players. Pick from the 4 remaining players. So there's 4 remaining players. And on Sunday, that means your choice is down to really 3 out of those 4. If you want to make sure that this doesn't happen, what he's saying here is that there is no forward picked on both Saturday and Sunday. So we don't want the same player picked twice, basically. So to ensure that, you must pick from the remaining 4 players on the Sunday. And then the final part of that, just to finish up, is that the probability is the number of desired outcomes. Always go back to our definition of probability. Probability is always the number of desired outcomes over the number of possible outcomes. So what's desired? We need 3 of these out of these 4. So it's 4C3 above the line. What's possible though is any 3 out of the 7 players. That's below the line. And that gives you an answer of 4 out of 35. And that's the end of the question.